There you go. Have you had any tests recently, or have you got any mocks coming up?
No, but I have a task coming up.
No, okay. Have you been given a revision list or anything?
Yeah, shall I go?
Yeah. What you
I'll
can
try and find
do?
it now.
Yeah, no problem. You get
Assessment revision.
if you one sec. You can get on the screen. I can get on the screen now. So there you go.
So it's uh standard form,
Right. So
angles.
have you got the list in front of you?
Yeah.
You
So I
mind
said,
just can you can if you can either take a photo and put it into the chat. So you can put it into there, or you can just put it up to the camera if you want.
I'll send it on the chat.
Yeah, no problem.
I can save it.
Because I can get you some questions on the stuff on the topics now as well.
So, I know. Then I can get it too.
Yeah, it can be a bit of a pain. No worries.
Uh,
If you want, you can hold it up to the camera for a sec. I can just screenshot if you want.
yeah, I'll do that now.
Yeah, it's no problem. Yeah, no problem. I think I can see it. One sec.
I'll try and get a light on.
Ah, that's okay. I think I can see it. You can send a screenshot of it if you want, but I think I've got it. Let me just hang on one sec. 1 second. I can just clean it up a little bit, no problem.
I'm unsure of how I can send
No,
this.
no problem. That's fine. Just 1 sec. Uh, uh, Let me just see if I can use AI to clean it up. Um, 1 sec. Let me just get Grok to do it. 1 sec. Um, where is Grok? Uh, Sorry, let me take a sec.
No, it's okay. I'm trying to get it as well.
No, so I mean it's it'll clean up for me now. It's no problem. It's not your fault. It's my camera. Yeah, it is managing it. Stay 1 sec. Yeah, quadratics you've got, quadratics. No, it's saying year 11 A level pure as well. Is it eight? It shouldn't say that, should it? If you're GCSE,
For what?
it doesn't.
No,
It doesn't have A level on there. No,
no.
no. That's fine. Um, yeah, it's not A level. It's saying A level, but that must be wrong. That's fine. No problem at all. What we can do, we'll just have a look at some of the topics. I'll just share my screen. Um, just share it again. There we go. And
I'll try and get you a
it's
better.
it's no problem. That's fine. Like, can you see my screen? Okay.
Yeah.
Yeah, that's fine. So it was. So I know you had surds on there.
No.
No, that's fine. So
It
you
was standard form.
yeah,
Angles, which is like parallel lines around a point, quadrilaterals,
yeah,
straight line.
that's really easy. I think we did
Yeah.
that ages ago. That's fine.
Algebra, which I've already done, and it's
We've
like
done loads of those.
expanding brackets,
Yeah, we've done
form
loads of those.
equations,
Yeah,
and
that's
then
fine.
it's indices, the laws, negative indices, and fractional
Yeah,
indices.
that's fine. We can do those.
Uh, and then
Yeah,
it's upper and lower bounds, which we've already covered. So
yeah, we've done those. Yeah, that's fine. So
it's only really standard form.
if we look at standard form, we'll look
Yeah.
at non-calculator first because it can come up in both, but with when it's on
Yeah.
calculator, it's really easy anyway. So let's make that master Y.
Yeah, I kind
Um,
of get it though anyway, because we've got to cover it in science and
yeah, you do it in science as well. Am I recording this? Yeah, okay, right. So if we look at it can come up in maths and in numeracy actually. So let's look at some numeracy ones. Numeracy booklets. Yeah, standard form higher tier. Question two, calculator was allowed. So this one is non-calc. Um, yeah, so with standard form, let's look at calculations.
yeah.
So with standard form calculations, I would say when multiplying oh, and dividing, we work separately and use laws of indices. So these are all on calc actually. So let's do. We'll start with a times in. Let's have a look at this question. So say we've got this question here. Um, I'll
Uh-huh.
put these questions into the chat as well, so you can have the link for later on. Um,
Yeah.
right, so the first question is just to write 6 million in standard form. So that should be really straightforward because obviously 6 million is just six with 6 zeros.
Yeah, so that would be
So yeah, so how would we put this into standard form?
6 million, six three zeros. That would be 6 times 10 to the power of 6.
Yeah, so can you see what I'm doing here? So I put the
Yeah.
decimal in, I go backwards until I'm after the first significant figure.
Yeah.
So it
Okay.
is 6.0 or just 6 times 10, and it's 6 arches back. So it's 6 times 10 to the 6.
Yeah. Oh, okay. Yeah.
So how would I write 0.0043 in standard form?
So that would be no, no, 4, 3. That would be 1, 2, 3. So that would be 4.3
Yeah,
times 10 to the minus 3.
yeah, brilliant. And it's minus 3 because it's 0 point something. So whenever it's 0 point something, it's a negative power. Okay,
Yeah.
that's great. So with this calculation, though, we need to multiply in standard form.
Okay. Yeah. Oh, yeah. Okay.
So what we do, we look at the number parts. So that would be the 8.4 and the 2. We would times those together. So that's obviously 16.8.
Yeah,
And then we look at the powers of 10. So it's 10 to the 3 times 10 to the 5.
which is 10 to the 8.
That's great. Now,
Yeah.
that answer is not in standard form.
Yeah, because it's got to be under 10
Yeah,
and
brilliant.
over 1
So if I make the 16.8 10 times smaller, I'll get 1.68.
to the 10 to the power of 9.
Yes, brilliant, because you have to times, so you divided the 16.8 by 10,
Yeah,
and to keep the number the same, you times the 10 to the power 8 by 10.
okay.
That means you effectively times by 1, so you get 1.68 times 10 to the
Yeah,
9. Okay, so if I give you one you can just do on paper, if you have a go at, we'll do 3.2 times 10 to the 4 times 2, well, I'll do times 4 times 10 to the minus 3, and I'll do minus 5. No, let's do minus 8, make it harder. There we go. So if you have a go at that one, is that okay?
yeah,
So we want to do it and put the answer into standard form.
okay. 4.8 times 10 to the minus 4. 1.28 times 10 to the minus 3.
So we get 12.8 times 10 to the minus 4. So you get 1.28 times 10 to the minus 3. That is great.
Yeah,
Yeah, no issue with that one. So with dividing, it's the same idea, but obviously these are a little bit more difficult. So let me
yeah,
get this one. This is a good one. Let's try this one. So this again would be a non-calculator, which looks a bit hard, but effectively, we once again look at the number parts. So we have 5.3 and 9.1. So we would do first 5.3 over 9.1.
yeah.
Now, if I wanted to do that divide, what would I need to times top and bottom by first?
9.1 would it be? No,
Well, if I want the bottom to be a whole number, what would I have to times top and bottom by?
10.
10, brilliant. So we have 53 over 91. Now, if I look at that, we'll see five. Now, 53, I don't actually know if anything goes into that. Um, so I don't see actually how you could simplify it. So let me have a look what that actually works out as, because that one doesn't actually go. Right, that one doesn't simplify. So with this one, this would just be a calculator question. Sorry
Yeah,
about that. So
no, it's
that
fine.
would just be 5.3. You just put 10 to the minus 6 over 9.1, 10 to the minus 5. So I'll just,
10 to the 5.
no, 10 to the 5, yeah. Yeah, that just gives us like 5.82 approximately times
Yeah,
10 to the to the minus 12. So there's nothing to do with that one really. So let's look at without a calculator that we can actually do. So let's say we had 2.6, um, no, let's do 5.4 times 10 to the minus 3 over 2.7 times, uh, that's, yeah, times 10 to the 4. So if I wanted to do this one, I would do 5.4 divided by 2.7.
which would be 2.
That's just 2 because obviously, again, you can times top and bottom by 10, giving you 54 over 27, which is 2.
Yeah,
And then we do 10 to the minus 3 divided by 10 to the 4. So what is that going to be?
Would that be 10 to the minus 7?
Excellent. Yeah, minus 3 take away 4. So we have 2 times 10 to the minus 7.
Yeah.
That's great. Let's try, um, say we had um, 4.5 times 10 to the 8 over 1.5 times 10 to the minus 3. So if you have a go at that one. Actually, no, I'm going to change that. Let's do 1.5 times 10 to the 8 over, let's say, t would be, let's do 7.5 times 10 to the minus 3. So if you have a go at that one.
5, whatever.
Yeah, good. So think about what that would be as a decimal. That's great.
0.2.
Yeah, so 1.5 over 7.5 is zero point 0.2. Well done.
Times 10 to the power of 11.
Excellent. Yeah, because 8 take away minus 3 is 8 plus 3, which is 11.
Yeah.
And then how would you get that into standard form?
Isn't that? Oh, no, that isn't standard. You times it by 10.
Yeah, you want zero point 0.2 times 10.
That would be 10 to the power of 10.
Excellent. Yeah, 2 times 10 to the 10. That's more the sort of one you get with a divide. That's great. Okay. That's brilliant. I'm just going to look at MathSwatch to get some more questions.
Okay.
I got my old, that's the old one. Uh, I haven't got the new one. Use the old MathSwatch. If it will let me, it might not let me use it. I'll see if it will. Um, there we go. Uh, Change the, you guys have my calculation. There we go. Right, let's say we had some adding and taking away.
Okay.
So let's say we had this. So we've got 2 times 10 to the 5 add 3 times 10 to the 4. So
Yeah.
what I would say with adding, you've got two possibilities. So you can either write them as normal numbers,
And then add. Yeah.
yeah, then add, then write in standard form again.
Yeah. Well, that would be easier.
It's easier, but the quicker
Well, yeah.
way
Yeah.
is to make the powers the same. So I think the second way is probably the best way. So you've got a 10 to the 5 and a 10 to the 4. So how would you make this 10 to the 4 into a 10 to the 5?
Times it by 10.
Brilliant. So you could have the second number as zero point 0.3 times 10 to the 5.
Yeah.
So effectively, you've got 2 times 10 to the 5 add zero point 0.3 times 10 to the 5. So how many lots of 10 to the power 5 would you have?
2.
2.3?
Yeah.
Yeah, so you've got, does that make sense there? Like, you think about it as 2x plus 0.3x, what would that be?
That would be 2.3x
Yeah,
squared. No,
x, just 2.3x. So because
2.3.
you're not timesing them, you
Yeah.
don't have an x squared. So you just got
Yeah.
2.3x. So instead of x, we really have 10 to the
2 point,
5.
it'd be 2.3 times 10 to the pi. 10 to the
Yeah,
5.
that's it. And that's already in standard form. So it just does it in one go.
Mm-hmm.
Okay.
Yeah, yeah.
So the only reason I suggest that is because you might have a question like, um, because you could have, for example, you could have 3.2 times 10 to, it could be like distance between planets or something like that. So 3.2 times 10 to the 23, take away 2.4 times 10 to the 22. It could be, or 21, it could be like that.
Oh yeah, okay.
So with this second one, what could you do to make the powers the same? There's two different ways you can do it.
So 3.2 times 10 to the 23 minus 20. 10 to the 20. So you would do you times well, you divide them both by 10. Divide
Yes.
the right one by 10, and so you get 0.024 times 10 to the power of 23.
Yeah, so what you've done is you divided that by 100,
Yeah,
0.024
yeah.
times 10 to 23, yeah, and you can just work with that then. So you've got 3.2 times 10 to the 23, take away 0.024 times 10 to the 23, and then you could just do 3.2, take away 0.024, and then put the times 10 to the 23.
Yeah, which is 3.176.
Uh, yeah, 671. So yeah, 3.176 times 10 to the 23. And again, that's already in standard form. So if you have one like that, you'd have to do it this way. Okay, that's great. Um, so let's have a look at this one. So I think this one would be a calculator one. This is a good question here. So 340,000 tomato seeds weigh 1 gram. Um, yeah, this actually would probably not be a calculator question, actually. Um, so first of all, we want to write the number 340,000 in standard form. So if you have a go at that.
3.4, 3, 5.
So
3.4 times 10 to the 5?
brilliant.
Yeah.
And then calculate the weight in grams of one tomato seed. So what do they even say? So that's 1 gram. So the weight in grams of one tomato seed. It's a bit of a mean one, actually. Well, so effectively, what calculation would you have to do there? I think this would probably be a calculator one.
Would it be just 1 gram is calculate the weight in grams?
Yeah, because 1 gram is 3.4 times 10 to the 5 seeds.
We calculate the weight in grams of one tomato seed, so that'd be that 3.4 times 10 to the power of 5 divided by no, 1.
Yeah, 1,
1 divided by 3.
yeah, 3.4 times 10 to the 5.
Yeah,
Yeah, so
that,
that would, again, that would probably have to be a calculator question there.
yeah,
So you'd have, I mean, again, if it was like, well, we'll do it with a calculator, but I'll show you another one. So that'd be 1 divided by 3 times 10, sorry, 3.4 times 10 to the 5. So to two significant figures, that is just 2.9 times 10 to the minus 6 grams.
okay, yeah,
But you could have, say, 1 divided by 2 times 10 to the 5. You can have that. how would you work that out without a calculator?
You do 1 divided by 2 and then times it by, no,
So, yeah, you do 1
yeah,
divided by 2.
but then it'd be 0.5.
Yeah,
But would you need to put a minus in front of the,
yeah, brilliant. Because the 10 to the 5 is on the bottom, it would be times 10 to the minus 5.
okay.
And then what would that be in standard form?
That would be 0.5 times 10 to the minus 6.
Yeah, that 5 times 10 to the minus 6.
Yeah.
That's great. Lovely. So let's have a look at one, have a look at maybe a numeracy one, because there's a higher numeracy one here. Um, there was a really nice one actually with, in fact, there was a good one that came up in 2017. Let's look at that one. I think it was 2017 at one. There we go. This is a good question. So this is actually, again, a non-calculated question. Let's have a go at this one. Right, so yeah, this is from 2017. So a standard piece of A4 paper is usually 0.08 millimeters thick. What is 0.08 millimeters written in meters in standard form? So
Um,
how do you think you would do that?
you'd find out how much you need to divide by in meters
Yeah, because we're going from millimeters.
to meters.
Yeah, yeah. So how would we go from millimeters to meters?
Millimeters to centimeters to meter
Yeah, you could do that. So millimeters to centimeters.
times 10.
Well,
Is it? No, yeah.
the way I would think about it is if I've got meters, centimeters, millimeters, if I want to go from a bigger unit to a smaller, you would have to times.
Yeah. Yeah, that's true.
So like, how would I go from meters to centimeters?
Times by 100
And then how would I go from centimeters to millimeters?
times by 10
How would I go the other way?
times by, divide by 10.
Excellent. Yeah. And then it would be divide by 100.
Yeah. So then that would be divided by 1,000.
Brilliant. So the calculation you've got to do is 0.08 divided by 1,000.
Yeah.
Yeah, that's it. So then you've got to work that out and then put it into standard form. So have a go at that.
That would be the end one.
Yeah, 8 times 10 to the minus 5.
Yeah.
Brilliant. So basically, the so yeah, that's brilliant. And then with B, we're now looking at a piece of card, which is obviously thicker. So a piece of card is 1 millimeter thick. A stack of these pieces of card is 3 times 10 to the minus 2 meters high. We want to work out how many pieces of card there are in the stack. So I would say you'd want to make sure the units are the same first.
Okay, so you got to put 1 millimeter into standard form.
Yeah, put it into meters. You can do that.
Yeah, meter for standard. Yeah.
Yeah, so if you put that into meters, you should then be able to work out what you need to do.
That's not wait. Yeah. So that would be 1 to the 10. That'd be 0.001,
Yeah,
which is 1 times 10 to the minus 3 in
brilliant.
standard form. So that would need to be,
Yeah, so that's that's how thick the card is. So then what calculation would you need to do?
3 times 10 to the minus 2 divided by 1 times 10 to the minus 3.
Brilliant, because now the units are the same. There you go. So you should be able to do that.
That is 3 times 10 to the 1.
That's it, which is 30.
Yeah.
Yeah, that's brilliant. And the assumption there is that all the pieces of card are the same thickness, but that's stupid because that is what the question says anyway. So yeah, that's brilliant. Um, that's the whole thing for that one. That's great. Maybe we'll try, there's a higher question here. We'll do. Um, right, so question. So this one's a calculator question. There you go. Right, so um, right, so Hella has been employed to deliver 3 times 10 to the 5 tons of sand. She's been given the following information about the sand. So we've got the mass of 1 grain of sand, and we've got the volume of a grain of sand in millimeter cubed.
So we got all different.
Yeah, so it's different units there, but what we can say, we want to work out the number of grains of sand in 3 times 10 to the 5 tons of sand.
We've got to put it all in tons. Oh
Well, we've
no.
been given well, you could either put the 1.2 times 10 to the minus 3 grams into tons, or we could put the 3 times 10 to the 5 tons of sand into
Into grams.
grams.
Yeah, that'd be easier, I'd say.
So if we think about the units, you've got tons is the biggest unit of mass, then kilograms, and then grams, and there is milligrams. We don't tend to use it. So we want to change tons into grams. So we need to remember how to go from tons to kilograms and then kilograms to grams.
Okay. So that's times by 100? 1,000.
1,000 for tons to kilograms, and it's also 1,000 from kilograms to grams.
Yeah, so that's times by a million.
Yeah,
Just add 6
times 10 to the power 6. So we have 3 times 10 to the 5
times.
times, yeah, 1 times 10 to the 6.
Yeah, which is 3 times 10 to the power of 11.
That's great. So you've got 3 times 10 to 11 grams.
But how do we, well, does the volume matter?
Well, we want to work out well, we know the mass. Well, yeah, this isn't even to do with the volume yet. That's true. So we know the mass of 1 grain is 1.2 times 10 to the minus 3 grams. So what calculation would I have to do to work out how many grains of sand are in 3 times 10 to the 11 grams?
You divide 1.2, 1 gram to the amount of grams.
Well, what we're asking is how many lots of 1.2 times 10 to the minus 3, how many lots of that will go into 3 times 10 to the 11?
So will it be 3 times 10 to the 11 divided by 1.2 to the...
Yeah. And this is a calculator question.
Okay.
Although, to be honest, I mean, uh, could come up on a non-calculator. I mean, this is a calculator question, so you could just pop it in. But if we didn't have a calculator,
Yeah, I
how,
can do that.
yeah, how would we do 3 over 1.2 without a
You
calculator?
times them by 10, so it'd be 30 over 12, and
Yeah,
then bus stop method.
yeah, you could use the bus stop there.
2, 0, take over the 6. That'd be 2.5.
2.5. So we have 2.5 times 10 to the
14.
14. Fantastic. I don't even know why it's a calculator one actually, because that could be on both.
Yeah.
So we've got, so in 3 times 10 to the 5 tons of sand, because obviously that's loads of sand, it's 2.5 times 10 to the 14 grains of sand, which is like,
Oh,
um, yeah, it's like trillions. 10 to the 12 is trillions. It's like 25, no, 250 trillion tons, grains of sand.
that's a
So
lot.
then, yeah, so then for two, calculate the volume of the 3 times 10 to the 5 tons of sand in meter cubed. So we could do it in millimeter cubed and then change it.
Yeah.
So we know that 1.2 times, well, don't know in terms of, so that's, well, what you said actually, you said 1 grain of sand. This actually isn't too bad. So you said 1 grain of sand is 0.32 millimeter cubed,
Hmm.
but we've got 2.5 times 10 to the 14 grains.
Yeah.
So how would we work out how many millimeter cubed that many grains of sand is going to be?
You divide it
Well, if 1 grain is 0.32, what have I
by,
times the 1 grain by to get 2.5 times 10 to the 14?
you've times it by one, 1 times 10 to the power 6.
Well, to go from one, I've gone from 1 grain to
To that would
2.5
be,
times 10 to the 14.
you times it by 2.5 times 10 to the 14.
That's great.
So you times that by 2. Yeah.
Yeah, that's great. So again,
Okay.
I mean, that, yeah, and it is,
That'll be calculated.
yeah, that would be, I mean,
We
two,
could solve it,
four,
but
yeah, I mean, I think it would be, I think it'd be zero point 0.8. I think 0.32 times 2.5, I think that's zero point 0.8 in my head. But again, you have a calculator now. So in my head, I think that's going to be 8 times 10 to the um, 13. That is what it is. Yeah.
hey,
There we go. So we have 8 times 10 to the 13 millimeter cubed.
yeah, but we
Now,
need to make it into meters cubed.
yeah. So again, let's think about we need to think about meters and millimeters. So how would I go from millimeters back to meters?
Times it by 1,000.
Divide by 1,000?
Yeah, divide
Yeah,
it.
millimeters back to meters. So if I want to go from millimeters cubed to meters cubed, what would you divide by that?
Is that divided by 3,000?
Well,
No.
it's going to be, well, to go from millimeters to meters, you would divide by 1,000. So millimeters cubed to meters cubed, you would divide by 1,000 cubed.
Yeah.
Because if you have a box which is, say that is 1 meter by 1 meter by 1 meter, the volume of that would be obviously 1 meter cubed. But then if you wanted the volume in millimeters cubed, well, 1 meter is 1,000 millimeters. So it's like you've got 1,000 millimeters for each of the lengths.
And then you times them together.
Yeah, and if you times those together, you would have 1,000 cubed
Yeah, okay. Uh,
millimeters cubed, and they are the same.
okay.
Yeah, so you need to do 8 times 10 to the 13. Well, what is 1,000 in standard form?
That is 1 times 10 to the
3.
power 3, but
So
that
what would
be
that be cubed?
9.
10 to the 9. So effectively, you need to do 8 times 10 to the 13 divided by 10 to the power 9.
Yeah,
And again, we don't really need a calculator for that either. What would that be?
10 to the power 4.
Yeah, so it's 8 times 10 to the 4, and now it's in meter cubed.
Yeah,
Is that okay?
yeah.
So I mean, that's probably the hardest they could give you on standard form. You might get a population density question. Of course, you've done that in geography. I think we did population density before with upper
Yeah,
low bands.
yeah.
They might give you one on that, but otherwise, that's basically what you'd have. Are you happy putting it into your calculator with the 10x button?
Oh yeah, yeah, yeah.
That's really fine. So we'll look at some indices, and then we'll maybe look at some bands questions. So we look at indices, um, locus mass indices. So right, so basically, you've got the rules of indices. So if I have, so I've got a to the power of n. Sorry, I'll just write it because it's doing weird stuff. So a to the power of n times, say, a to the power of m is going to be a to the power of n plus m.
Yeah,
So
yeah.
like, that's like 2 cubed times 2 to the 4 is 2 to the power 7. So as long as the big number is the same, you can add the powers. So
Yeah.
then if you divide, as we've done already, take away the powers. And then as you did before with the 10 cubed,
Yeah.
if you raise something which is already raised to a power to a new power, you times the powers.
Okay. Yeah, yeah,
Yeah.
yeah. We did. Yeah,
And then with fractional indices, so let's say I had a to the power of n over m, you
yeah,
get the mth root of a, and then you raise that to the power of n.
yeah, yeah, yeah.
And if you have a negative power, so like a to the minus x, all that means is you put 1 over and then you do a to the power of x.
Okay.
Okay, so
Yeah,
that one,
yeah,
they
yeah,
look a bit complicated, but let's just practice it.
yeah.
So let's say I had 16 to the power of a half. That would be the second root of 16, which is just the square root, and then all to the power of 1, which just leaves it the same.
Yeah.
So what is that going to be? The second root is just the square root. So what's that going to be?
At eight?
What's
No,
the square root of 16?
four,
4. So it's just 4 to the power of 1, which is just 4.
four.
So like power of a half is a square root. So if I had 25 to the half,
That'd be five.
that would be 5. If I had 8 to the power of a third,
That would be two.
2. Cube root, fantastic. Um, if I had 3 to the power of minus 2, what would that be?
That would be two.
So what we do when there's a minus power, you put 1 over, and then you just do the same. Then you do the question as though the minus wasn't there. So you've now got 3 to the power of 2.
Yeah.
So that's 1 over, and then what is 3 to the power of 2?
Nine.
9. Brilliant.
No point
But
three. Three.
yeah, that would be 0 point, well, 1/9 was like 0.1 recurring, but 1/9 is fine. So then with that in mind, what if I had 16 to the power of minus a half?
You'd
So
have. So what's minus? Would that be one over two to the cube root square root of 16?
yeah, 1 over the square root of 16.
That'd be one over four.
Fantastic. Brilliant. Let's say we had 8 to the power of 2/3.
That
So
would be yeah, that
yeah, so it's going to be the bottom number is the root, and then you raise the answer to the power of the top number.
cube root of four.
So yeah, it's going to be brilliant. The cube root of 8 is 2, squared is 4. So we have 4. Brilliant. Um, let's say we had let's say we had 16 to the minus 3/4. So if you haven't got that one, that's quite a tricky one.
That would be 16 minus 16. Uh, the bottom number, would it be rooted to?
Yeah.
Be over 1. Would it be over 1? Yeah.
There's going to be 1 over.
4 root 16
Yeah, so it's going to be the fourth root of 16 cubed.
and cubed. Okay. So that would be 4, 2. No.
Yeah. The fourth root of 16 is the square root of 16, and then you square root it again.
Yeah, so that'd be 2.
Yeah.
Then it'd be the answer is 8.
1
1 over
eighth.
8. Yeah.
Brilliant. Really good. Um, right, this is the hard one. What if we had 27 eighths? It's a good one. To the power of minus a third. So for this, you've got to do 1 over 27 eighths to the third. Now, when you've got 1 over a fraction, oh, to the third even. When you've got 1 over a fraction like that, it's like if I had, say, 1 over a half, you would end up with 2 over 1 or 2. So
Uh-huh.
when you've got 1 over a fraction, you can just flip it over. So we'd have 8 over 27 to the power of a third.
Oh. Oh. Okay.
And that would just give you 8 to the power of a third over 27 to the power of a third.
Yeah,
So then what would that simplify to?
that'd simplify to, so this cube root of 8 is 2,
Yeah,
and the cube root of 27 is 3.
yeah. So you just end up with 2/3 there.
Yeah, okay.
Brilliant. So what if I had, say I had 1/9 to the minus a half. So have I got that one?
Would be 1 over,
Yeah, so 1 over, so that would flip it over.
so that'd be 9 over 1 to the square root. That'd be 3.
Yeah, brilliant, because it's effectively root 9 over root 1, which is just 3 over 1, which is 3. Brilliant. Um, that's great. Um, so let me have a look for these. So let me have a look for a difficult one there. Uh, so it'll obviously be in the second half. Yeah, these ones are good. Have you got recurring decimals on this test as well?
I am not sure.
No problem. Um,
I'll check. Um, for the indices,
yeah,
just negative and fractional.
yeah, brilliant. So this question was in 2023. So if you have a go at these two, is that okay?
Yeah, 64 to the 3. That would be 2 over 3. 65 and 8. Is that 1/2? That be a half? No. No.
Well, there's no minus in it. So you've got 64
Oh.
to the 2/3.
Ah.
Yeah,
So
so
that would
think,
be 3. That would be 4 squared. So that'd be 16.
yeah, brilliant. That's all it is. Fantastic. Great. So then you've got 10,000 to the minus half. So have a go at that one.
That would be okay. So it's to the minus half now. So
Yeah.
that'd be 10,000 root 2 over 1. It should be
Yeah, one over.
uh, ah, 1 over 100.
Yeah, 100th. Give us one over the square root, sugar, one over the square root of 10,000. One over 10,000 is 10 to the 4. So that's 1 over 10 squared, which is 1/100th.
Yep.
Yeah, that's brilliant. Um, so so you've got bands, so we'll have a look at a question on that. Um, so I don't know if there'll be any in the math section or the numeracy. Upper and lower bounds, it can come up in both. This is more maths. Uh, well, these ones are all quite straightforward. Let's look for a harder one. Yeah, these are higher tier ones. Spinning tool. Now we've done a lot of these questions actually. I know we did all of these questions, in fact. There's a standard form. We did all of those. I think that's probably fine. Let's look at, so obviously you've got algebra. Um, so that's like quadratics.
Yeah. Solving equations.
Yeah, so solving like factorizing quadratics.
Yeah.
Yeah, so we go this one. These aren't really good questions, to be honest. Let's say,
Oh, wait, no. It's expanding brackets,
yeah,
substitution using a formula,
yeah,
solving equation, x's on both sides of the equation, solving equations with fractions and forming equations.
yeah. So let's do, um, let me have a look for one of these. Oh, this makes up here. So let's have a look at, so we've got 2x plus 4 equals 12x minus 3, or, right, so say I have this equation. So what could we do first to solve this equation?
You put x on one side of the equation and then four numbers on the other side of the
Yeah,
equation.
so we want all the numbers on all the x on the same side. So which side should I put all the x's on?
The left side.
You can do the left side, that's absolutely fine. I would only say the right side because there's more x's on it.
Yeah. Okay. And yeah. Okay. So it'd be 10x and minus 5.
So we take away 2x from both sides, yeah. Yeah, that's exactly right. So we take away the 2x from both sides. So we get minus 8 equals 10x minus 3. And then we could add 3 to both
3.
sides. So
And
minus
then
5 is
10.
10x.
And then you'd put 10. You'd divide by 10 on both sides. So you get x equals minus 1/5, 1/2.
Yeah, x equals minus a half. That's great. Um, so we can, yeah, so x on both sides is fine. What if, let's say I had 2x minus 3 over 4. It's all over 4 equals, say we had 5x. I don't know if this is going to be nice numbers. Take away 8. So what would I have to do to solve this equation?
You'd have to times both sides by 4.
Yeah, yeah. So have
Okay.
a go. Yeah, have a go at solving that one. That's great.
Okay. Will be That'll be x equals 29 divided by 18.
Yeah, it's not nice. But sorry. So 2x minus 3 equals 20x. Take away 32.
Yeah.
So 32. I end up with 35 equals 18x. So x is 35 over 18.
How?
So I've multiplied both sides by 4. So I have 2x minus 3 on the left.
Yeah.
Now on the right-hand side, we've done 4 times 5x minus 8,
Uh-huh.
which simplifies to, because you can expand that, to 20x minus 32.
Yeah.
So we have 2x minus 3 equals 20x minus 32.
Yeah.
So I would take away 2x from both sides,
Uh-huh.
giving you minus 3 equals 18x, take away 32.
Yeah.
Then we would add 32. Oh, you are right. Sorry, it was 29. We add 32 to both sides, giving you 29
Yeah.
equals 18x. Yeah, my mistake there.
No, that's fine.
That's fine. So we get x equals 29 eighteenths.
Yeah.
Um, right, so that's brilliant. So in terms of forming equations there, because I presume there's going to be some quadratics there as well.
Yeah.
Um,
Fine.
did you say surds as well?
I don't think so.
That's fine. My mistake there. That's fine. Um,
No.
let's have a
Miss
look
it.
at this. Have a look for a good question on this. Um, I mean, this one is forming a quadratic. Um, Standard form. That's inequality. Um, so this one now, this is algebraic fractions, but I would say this one is a quadratic one. So we've got this equation we want to solve. So what can I do here to deal with the fractions?
You could times First you could times both sides by x plus 1, and then you
Great.
could times both sides by 4 minus 5.
4x minus 5. Yeah, so what would that look like then?
That would be x plus 12 equals 2 x minus 5. So that would be, so your times in it by, so that would be 4x squared minus 5.
Yeah, so firstly you get to this, yeah?
Yeah,
Then you could expand. Yeah, so if you expand the brackets on both sides, that's great.
would that be 4x? No,
Yeah,
that'd be 5.
4x squared, because you're doing x times 4x, that's 4x squared. And then x times minus 5,
Yeah.
minus 5x.
Uh-huh.
Yeah, and then what would you have on the right-hand side?
Uh, 2x plus 1.
So
2.
brilliant. So this equation we can see is a quadratic. So we would need to get all the x's. We need to get everything on the same side and make it equal to 0.
Yeah. Yeah.
Yeah. So we have. So what would that be if you made took everything to the same side?
So that would be 4x squared take away 7x minus 2
That's great.
equals 0.
Brilliant. So I'm not sure if you have quadratics on this test, but do you remember how you would factorize this?
Uh, um, no,
I'll just go through that. But again, I don't know if it's even on this test. I wouldn't worry too much yet. But
I don't think so.
just, yeah, it was been a while since you've done it. So we would times 4 by minus 2. So that's minus 8. So we want a pair of numbers that will times to give minus 8, and they will need to add to give the number by the x, which is minus 7.
Yeah.
So that would
I think I remember.
be minus 8 and 1, because they would times
Yeah.
to give minus 8, add to give minus
Yeah.
7. And then
Uh,
instead of minus 7x, we just write minus 8x, add 1x.
okay.
And
Yeah.
then you can do the double
That,
factorize. So could you factorize 4x? How would you factorize 4x squared minus 8x? What would you take out?
you take out 2x.
4x?
Yeah, 4x. Oh
No
yeah,
problem.
4x.
So you've got 4x bracket x minus 2.
And
And
then, yeah, that's the same over there. So it'd be 4x times x minus 2 squared.
yeah, so we get 4x plus 1. So everything outside of the brackets,
And then it would be, yeah,
x minus 2.
yeah,
And then you just have either x is minus 1 over 4 or x is 2. Because
yeah,
what you do is you make 4x plus 1 equal to 0 or x minus 2 equal to 0.
yeah, I remember that.
Okay. So that's brilliant. So what I'll do, I'll send some questions over that you can practice with. Might have to be later this evening though, because I've got a few other things on first. But I'll send you
Yeah,
some questions over that
okay.
you can practice with. When have you got the test?
I have the test on the 23rd.
Okay, so it's a bit of a while away. What I'll do, I'll make some questions
Yeah,
and I'll send you the answers as
we
well.
should have a lesson the day before the test, I believe.
Oh, okay. Yeah, okay. Yeah, that's fine. So, well, I'll still send you some questions over anyway that you can practice with on the topics that you mentioned. I'll send you the answers as well. But I think you've got a good chance at it. So just have a go at the questions to practice, check with
Yeah,
the answers. I'll send you
yeah.
as
I'll have
well
a,
some.
okay,
So I'll send you some of my videos as well that you can watch on there. I've got loads of videos I've made on these topics,
okay.
um, and that should be fine. So just you should be fine then.
Yeah, we have
Okay.
one less. We have a lesson 2 days before the assessment.
Yeah, that should be
So we
fine.
can go over everything there.
Yeah, that's fine. Okay, so I'll send that stuff over as soon as I can. But
Yeah.
otherwise, just have a great week now. Okay.
Thanks. You too.
Bye now. Bye.
Bye.
Hello. Sorry, Laura, can you hear me okay?
Yeah, I can hear you now.
That's
Hi.
brilliant. So I'm just checking one thing. I just got off of the lesson. Let me just make sure that that lesson has actually stopped recording.
Okay.
Um, sorry, 1 second. Um, let me